Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. We are studying the new chapter which has been added into the syllabus of the physics. And today we are studying the chapter Earth and the solar system. And today we are going to talk about the Earth in this video. So the focus points of this topic will be, today's video will be, use the rotation of the Earth on its axis to explain the apparent daily motion of the sun and the periodic change between night and day. Use the correct equation to define average orbital speed. Day and night and the rising and setting of the sun can be explained by the rotation of the earth on its axis. In this section, you will learn more about these natural occurrences. The earth is the third planet from the sun and travels in a nearly circular orbit controlled by the large gravitational attraction exerted by the sun. The Earth takes 1 year to travel around the orbit. The moon orbits the Earth under the influence of Earth's gravitational attraction and always has the same area of its surface facing towards the Earth. You will learn how to calculate the average orbital speed of an object such as the moon or a planet. The Earth is a planet of the Sun traveling in a nearly circular orbit around the Sun, and the Moon orbits the Earth as a satellite. The motion of the Earth and Moon account for the occurrence of a number of natural events. Motion of the Earth, day and night, these are caused by the Earth spinning on its axis, that is, about the line through its north and south poles, and making one complete revolution every 24 hours. This creates day for the half of the Earth's surface facing the sun and night for the other half facing away from the sun. Rising and setting of the sun. The Earth's rotation on its axis causes the Sun to have an apparent daily journey from east to west. It rises exactly in the east and sets exactly in the west only at the equinoxes around 21st March and 23rd September. In the northern hemisphere in summer, it rises north of east and sets north of west. In winter, it rises and sets south of these points. Each day, the sun is highest above the horizon at noon and directly due south in the northern hemisphere. This height itself is greatest and the daylight hours longest about 21st June. After that, the sun's height slowly decreases, and near 21st December, it is lowest, and the number of daylight hours is smallest, as shown in the figure 6.11. So, this is the summer, equinoxes, and winter, west, and this is the east, rising and setting of the sun in the northern hemisphere. Orbit of the Earth. The Earth orbits the sun once in approximately 365 days, that is, in 1 year. The path of the Earth around the sun is not quite circular, but takes form of an ellipse with the sun at one focus. Figure 6.1.2 shows the Earth in 4 different positions in its orbit. Note that the Earth's axis is tilted at 23.3 degree to the plane of its path around the sun. Day and night are of equal length only when the Earth is at the points A and B of its orbit. These are the equinoxes, which often fall on 20 March and 23rd September. This is 20th March and 23rd March. This is the orbit of the Earth around the sun. And this is 31st June, 21st December. Motion of the moon. The moon is a satellite of the Earth and travels around it in an approximately circular orbit approximately once a month at an average distance away of about 400,000 kilometers. It also revolves on its own axis in a month and so always has the same side facing the Earth, so that we never see the dark side of the moon. We see the moon by reflected sunlight since it does not produce its own light. It does not have an atmosphere. It does have a gravitational field due to its mass, but the field strength is only 1/6 of that on Earth. Hence, the astronauts who walked on the moon moved in a springy fashion, but did not fly off into space. Phases of the moon. The moon's appearance from the Earth changes during its monthly journey. It has different phases. In figure 6.1.3, the outer circle shows that exactly half of it is always illuminated by the sun. How it looks from the Earth in its various positions is shown inside this. In the new moon phase, the moon is between the sun and the Earth, and the side facing the Earth, being unlit, is not visible from the Earth. A thin new crescent appears along one edge as it travels in its orbit, gradually increasing in size until at the first quarter phase, when half of the moon's surface can be seen. At full moon, the moon is on the opposite side of the Earth from the sun and appears as a complete circle. After that, it wanes through the last quarter phase until only the old crescent can be seen. Figure 6.1.4 show the surface of the moon partially illuminated as seen from the Earth. So here you can see this is the Earth. So these are the rays coming from the sun. So when the moon is here, it's totally dark. When the moon is here, you can see the quarter of the moon. And when the moon is here, you can see the full moon, and then is the last quarter. So these are the shapes of the moon which you will see from the Earth. The sun is here somewhere. These are the rays of the sun coming. So in the figure 6.14, the surface of the moon partially illuminated as seen from the Earth. Rising and setting of the moon. Like the sun, the moon appears to have a daily trip across the sky from the east, where it rises, to the west, where it sets. Again, this is due to the Earth's rotation on its axis. orbital speed. In the topic 1.2, we defined that the average speed is equals to the total distance divided by total time. So for the moon moving in a circular orbit around the Earth with average orbital speed v, so v is the v equals to circumference of that orbit in which the moon is orbiting. So the circumference of that orbit divided by the time the moon takes to complete that orbit. So the formula of the orbital speed will be 2 pi r, which is the circumference of the orbit, divided by the time taken to complete that orbit, where r is the average radius of the orbit, and that average radius will be also equals to the distance between the moon and the Earth, and the t is the orbital period of the time for one orbit. Key definitions: average orbital speed v equals to 2 pi r divided by t, where r is the average radius of the orbit and t is the orbital speed. So, my dear students, this lecture is over. So you see, we have talked about the orbital speed, we have talked about the phases of the moon, and we have seen the tilt on the axis of the Earth and why the day and night do we have. And we have also learned that how the sun appears on different heights during different seasons. So that was all about the Earth and its rotation and the orbital speed. So thank you very much for watching this video, and I suggest you that please watch more and more videos from the YouTube, see documentaries on the solar system, on the Earth, about the moon, about the stars, about the universe. That will help you to master these concepts, to clear your concepts, your imagination. Thank you very much. Have a good day. God bless you all.